Hello, my name is Carol. Welcome to the Good Code channel. As for my day-to-day work, I work at a company called the Software Hut, and subject I would like to tackle today is converting numbers between decimal system and different numerical systems, starting from the binary one up to hex. So when it comes to IT job interview questions, this is absolutely must-have. Let's go. Okay, so what's our goal? Our goal is to write a converter that will be able to convert decimal base numbers, so the one that we use on day-to-day basis, to different systems, from 2 base over here to 16 base over here. And we will do it over 3 steps, gradually becoming better and better and better. Okay, so we'll start with the basic topic that was asked of us, so converting to base 2. Let's see how to do it. I will take a breakpoint over here and hit F5 to run it with node.js. Okay, let's hide our console because we won't be needing it. Okay, let's hit F11 and we are inside of our function. Okay, no watch elements needed, and let's add only the ones that we'll be using. So first of all, we need a number. Second of all, we need a result. And I guess that's it for a moment. What's the idea behind converting? The idea behind the converting is that we have a result that will be eventually returned, like number 12. Okay, and what are the actions that we need to take to convert decimal base number to different numerical types? Okay, first of all, we need to calculate modulo based on the system we are converting to. So in that case, it will be modulo 2. Okay, so let's say number modulo 2 plus result. Okay, so we are setting it as a prefix of the result that we have. Okay, so let's hit F10 and we see that we have 1. After setting the result, we need to divide our number by the bare system and round it floor, so to the lower value. Okay, we do that. Now our number is 61. After that, we are checking if our number is greater than 0. It is, so let's do it again. Yeah, we have the same steps. So 61 modulo 2 will be 1, so 1 prefix to 1 is, let's say, 11, but it's not 11, but yeah, still. Okay, so once again, we need to divide by 2. We do it, and now we have 3, 0. Okay, once again, number is greater than 0, and the loop continues. Yeah, we have again and again and again. We are coming to an end. Now it will be the last loop, run of the loop, and now we see number modulo 2 will be 1, so 1 will be added to the front. When we finish the divide operation, now we have 0. So the result of converting 123 to decimal system is 1 1 1 1 0 1 1. And if we check in any kind of converters or do our own math, we will see that it's a correct answer. But this function, the one over here, is far from being perfect. Why? Mainly because it's very hard to test and it's not reusable in many cases. Okay, we only can change the number to base 2. Okay, let's see how to do it better. I will stop my program and uncomment those 2 lines. Those 2 lines are calling the next function I would like to discuss, the function that calls base 2 and base 3. Okay, in case of base 2 and base 3, we will only see the result because the way that it's being generated is basically the same. Okay, so what's the difference and why this function over here is far more superior over this function? The answer is fairly simple. Okay, let me just set a breakpoint over here, hit F5 and run in Node. Okay, the reason is we can provide the type. Okay, this function is reusable and there is no problem to convert number to base 2, base 3, base 7, whatever. Okay, the only difference is that here the number we are using is set to 2, and in this case this number is based on the parameters that we are providing over here. Okay, so let's hit F5. Now that the converting to base 2 was finished, we see that the result is absolutely the same. Cool. But thanks to this function, convert to base n, we are able to do something that wasn't able in the previous function, and that is converting to different numerical systems. Okay, I will hit F5 once again, and now our result is 1, 1, 1, 2, 1. Why? Because now our base is 3. Okay, so we are dividing by 3, and sometimes modulo can be 2. Okay, some of you who know what the numerical systems are will say, hey, but we can go up to 16 when it comes to this base number. What about this situation? Okay, in case of this function, it is impossible to get the correct result, because when we are converting to base 16, we are using letters. Yeah, letters in numbers, abomination. But no, it's quite cool. Okay, so we will stop it, and we will comment this part, and we will uncomment this part. Okay, and this is a little bit tricky, and I had my doubts about it, and I wasn't sure which way to go. Eventually I decided to go with option of providing the dictionary. Why? Because if for some crazy reason we would like to change A to X, B to W, I don't know, D to K, we are free to do so. So the number, the base number, and the dictionary is provided as a parameters. Okay, you can probably go without this one and set it and keep it inside the function, but I went this way. It's okay-ish in both cases. Now, where is the tricky part? The tricky part is over here, but we will see it once we start debugging. Okay, so I'll set a breakpoint on inline 27. I will hit running with Node.js, and let's run the function convert to base n full. Okay, full, because we can provide a dictionary. Okay, we're over here, and we have n, which in our case should be 16, and we have a dictionary which will help us to have letters in our numbers. Okay, yeah, cool. Okay, I will hide it. Now, result is undefined at this moment. Now it's an empty string, and let's see how it's done. First of all, we are dividing by 16, and the number is 270. Okay, so first, boom, we have divided by 16, and modulo from this division will be 14. Okay, there is no number 14 that we can set in one chart, so we are using the dictionary. Where we are using the dictionary over here. Look, we're not setting the result of the modulo in the result. We are setting element from the dictionary that was on the index that equals to this modulo. Okay, that's why we have E in the result. Okay, now we will do the division, and our number equals 16. Cool. Let's do it again. 16 modulo 16 will be 0, so we have 0 E. Okay, division one more time, we have 1, so last round, 1 modulo 16 will be 1, so 270 converted to hexagonal system will be 10E. Okay, and that's why this function is extra superior over the previous two. Okay, I can stop it now, because not only we can provide any from the reusable base systems, we can also provide a dictionary. Thanks for listening to it. I hope it was helpful. In case of any questions, comments, feel free to leave it on the video on the YouTube, and as always, the code that I was presenting will be available in the download link at the video description. See ya!